graders, welcome back. Just a little quick video for you guys to go over the pHet static electricity assignment today. So if you haven't already, this is obviously in Teams assignments. Go into assignments, you guys will need to open up the pHet link. It's also linked in the worksheet, it's linked on the assignment, and if you guys are just having a hard time finding it, you can just Google search pHet static electricity, and it's this first one, balloons and static electricity. And then you'll also need to open the worksheet, which is the Word document in the Teams assignment. Okay, so for the first part of this, there's two parts. You guys will use the pHet lab to help you guys describe these questions. Mainly you're just describing kind of what you guys see happening in here, and you have some little challenges to complete. Like the first one says, how can you make the balloon stick to the sweater? Okay, so you guys would obviously go into your pHet simulation, and you guys would mess around with this balloon to try to get it to stick to the sweater. You guys notice there's a couple different things. You guys can change whether you can see the charges or not, whether you see one balloon or two balloons, and then you can also get rid of this wall so you don't have to worry about that wall being in there for whatever reason, whatever challenge you have. You guys can kind of look at, can you make it stick strongly versus weakly? The plus or minus symbols show us charges. So how do you kind of use those to decide whether something attracts and sticks to each other or repels and moves away from each other? Can you make two balloons stick to the sweater, and if so, how? How can you make two balloons move apart so they'd repel each other? And then how can you make the balloons stick to the sweater strongly? So kind of explore that principle a little bit more from up here. Part two, you guys just have some follow-up questions. Pretty simple, but I'm going to go through a couple of them with you. So for this first one, you guys will be using these three balloons. So it says in the picture below, the balloons on the left and middle are held in place so you guys can see the little hand holding them. It's not allowing them to move. So those two balloons cannot move. Okay? Is it possible to add positive or negatives on this free balloon to make it move to the left? So I want it to move this way. Okay, so if so, okay, then how would you draw either positive or negatives on there to make it do that? If it's not possible, explain why it won't ever do that. Okay? Think about, for question two, think about when your clothes get staticky or when you pull things out of the dryer. And then also think, like, if you're talking dryer sheets, if some of you guys use, like, Downy or whatever the case is, how do those maybe help prevent this from happening? So think about why they stick and how a dryer sheet might help them. For this box, you guys have these little red negative charges. On the left-hand side, you can see the A, the B, and the C box. But the little black positive puck is free to move. So for each picture above, explain how the black positive circle would be moved if released. So if we let go of that black puck, that little black positive, and let it move, how would it move? Okay. Remember, the blue negatives can't move, but the black positive can. Same with this one. You guys have the blue negatives are stuck in place, but the black positive can move. So do you think the positive circle would move the fastest? So in which picture? So A, B, or C, which one do you think, if we let go of the black puck, would move the fastest, and why? Okay, in the pictures below, the middle positive black pucks again are free to move, but the red and the blue positive and negatives are stuck in place. So you guys can kind of see that right there. So you guys obviously won't be able to draw an arrow, but you guys can describe it down here. So it says for case A, so take a look at case A, we've got a negative that's stuck in place and a positive that's stuck in place, and then we've got this positive in between them that can move. So how would it move if it can? So first of all, can it move or not move? And in which direction? Okay, same with this one. These two can't move, but the black one can. So if we let go of that black one, would it move? Yes or no? And then in which direction? Same with C. The black is movable, but the red is stuck in place. So once you guys finish that up, go ahead, turn that in. That's your only assignment for today. It shouldn't take you guys very long. If you guys have any questions, please let me know. And as always, if you guys just want to say hi or anything else is going on, please shoot me a message in Teams and we can chat about it. And I hope you all are having a great day and had a good Christmas break. Bye.